Hey, Lori.
Hi, I'm Lori. Hi, how are you, Keith? I would just introduce briefly. I'm Lori King. I'm a software engineer at Thoughtworks with a special interest in infrastructure and DevOps. Today, I'm really excited to be speaking to an absolute legend who has fundamentally shaped how many of us think about and manage our infrastructure, Kief Morris, the author of the seminal book, Infrastructure as Code. With a wealth of experience, Keith has been providing strategic consulting and hands-on implementation leadership in various industries and guiding organizations through their cloud and DevOps transformations. The reason we're here today is particularly excited. Keith is going to introduce and discuss the brand new edition of the third edition of Infrastructure as Code. Keith, tell us what is new about Infrastructure as Code?
That's a good question. It's funny. So the first edition, I wrote that in 2016, and then I did the second edition around 2020, and a fair lot changed. Like the first edition was subtitled something about servers, and so it was very server focused, Chef and Puppet and that kind of stuff. There was like Terraform and CloudFormation and that kind of thing in there, but all the action was on servers. And then clearly over the kind of 4 years or so from 2016 to 2020, there was a lot more emphasis on the Terraform-y type stuff, cloud, IaaS, that kind of thing. But the server stuff was still in there. The third edition has gone even a bit more that way, I would say. It's funny, when I started working on it, I was thinking it's not going to be as much of a change, like in terms of how much I would kind of rewrite or add or what have you from the as it had been from the first to the second, but actually I ended up doing quite a bit. That was less about like, so that kind of shift from kind of servers, less of that kind of a shift, and more about thinking about how we kind of manage and define our infrastructure as code, thinking more about, say, componentization, organizing of code, also thinking about like deployment. So like a lot of the kind of tools that are around for managing how you deploy infrastructure as code. So there's a lot going on. So it's a lot more of, I guess, that kind of stuff, if that helps.
Well, that gives us a split, because I noticed that in the second edition you wrote that we have a long way to go. We're not there yet. Are we there yet?
Definitely
in terms of maturity?
Definitely not. I mean, I think I always say that like we are with infrastructure as code, where we were with software development, like maybe, I don't know, 15 plus years ago. I'll just quickly, I noticed somebody asked this, is this going to be recorded? Yeah, it's going to be recorded and shared. You'll be able to see it on LinkedIn, and I think it'll be posted on YouTube as well afterwards. No, I lost my train of thought. What were we talking? What was?
Well, we can go to this. Well, one of the things that you mentioned about design principles for this, and you do talk about cohesion and how this is linked to how similar to the software in terms of code we should have.
That's right. Yeah.
And could you talk a little bit more about that?
Yeah, so it's just that so like that train of thought that I had lost was around that, like, we're kind of still, I think, relearning stuff that we learned in software development, and we're still kind of figuring out with infrastructure how to apply it. So software design is absolutely a big thing. Like, we tend to, a lot of infrastructure projects get quite large quite quickly and are unwieldy. A lot of kind of spaghetti code, monolithic approaches, that kind of thing. And so I think that's just kind of something we're still working out, and like tool vendors are still working out what's the best approach, what are the kind of good, ways of letting people structure code. And then there's also just a whole kind of thing of like, is even code, the best kind of paradigm for how we kind of build infrastructure. So there's something I kind of refer to in the book, but don't get into a lot because it's very, I would say, nascent right now. It's like very kind of like early days. There's various kind of vendors coming up with tools for automating infrastructure, which aren't code based, which are based more on like having like graphs of data and that could be kind of like dynamically synchronized and all these kind of things. So I think that's some really interesting stuff as well. But like at the end of the day, like it's just really still hard, right? It's hard building infrastructure with, with code or otherwise. It gets really messy. You spend a lot of time just dealing with not even the infrastructure code itself, but like the stuff that you use to manage your infrastructure code and deploy it and configure it. So yeah, certainly this better not be the end of the, the final state of how we manage infrastructure, because it's not awesome.
Yeah. Okay, but if we do take, for example, if you enter into something, you see the spaghetti infrastructure, so to speak, what are some strategies for tackling that to make it a more manageable system? I mean, if we were using,
no, go ahead, carry on.
No, I mean, because if we were dealing with a code base, right, a monolith, we would start with creating our tests and try to break it out into smaller parts, maybe build into microservices. How does that apply? How is that applicable to infrastructure as code?
I think pretty much the same. So it is about breaking it into smaller pieces, using tests. I would say using pipelines to manage deployment to multiple environments and those kind of things. So I think it is a lot of those same things. That might look a little bit different with infrastructure code. And I think one of the things that I guess in terms of like the maturity of like the tooling and the things that were kind of given for this, I think they're not great. So for example, Terraform is the most popular tool, and the stuff that I just, the stuff that I tend to talk about and write about is kind of tool agnostic in a way. Like there are concepts that apply to whichever kind of automation tool you're using, Pulumi or CDK or Terraform, what have you. But Terraform has kind of driven a lot of the, I guess, the ways of thinking about it. So for example, the main component that you can use with Terraform is a module. But modules don't really help with it. So they help you to organize your code and maybe share and reuse code at the code level. But if you take like a big messy code base and turn it into modules, when you go to apply it, it still takes a long time because it still becomes one thing. So it's kind of like libraries versus a deployable unit for software. So I think we need to kind of progress that in terms of thinking about what the I guess the right ways to kind of split up and modularize code in a way that makes it easier to deploy. But then how do you orchestrate that? Just as with microservices, you break apart a monolith into multiple microservices, and then you have like another problem, which is how do you coordinate what goes on with all those? It's very much the same with infrastructure code. And then I think there's also the thing just in terms of, you're asking like what I guess what do we need to think about? There's the whole thing of like, so where do you kind of draw those boundaries then, even assuming that you have the mechanisms to split out your infrastructure code base into something more manageable? Where are the right boundaries? And those might not be the same, I guess, considerations as they are for software necessarily, because you have things that happen with infrastructure that happens differently. And so, maybe you need a different approach.
Yeah, that's a really good point. And it also reminds me of something about, because we're thinking about it in terms of the technical part, the implementation, right? But there's also a link. I mean, from the book there's a section on governance. So this also has something to do with like the business goals and the parts that play. You briefly talked about in chapter 5 about lightweight governance. So in your experience, what are the key elements of a successful lightweight governance for infrastructure as code, for particularly balancing team autonomy with the possible necessity of centralized control and standards?
Yeah, that's a really good question, because it's a really big challenge. And because obviously you get the situations, you get kind of those two extremes of, well, we're going to centralize, right? We're going to have a team that owns the infrastructure and they'll build everything and they'll build it, properly. And then other teams that need to use that infrastructure will just depend on them. And, that obviously has drawbacks in terms of that team becomes a bottleneck. And there's lots of like the kind of communication flows back and forth, raising tickets and so on, can make things very painful. When you go the other way and say, well, let's just have all the teams build their own infrastructure and manage it for themselves. And then everybody does different stuff and it's not necessarily compatible. They might be, some teams might be better at things like managing security. Other teams may not have those skills. And you may just have the kind of like everybody building duplicate things where, couldn't we share better? So I think for me, the really important thing is thinking about enabling teams to share, so to build and share infrastructure. How can you do that? So it's less about directing what teams build, I guess, with their infrastructure, and more how do you go about doing it in a way so that different teams' infrastructure can kind of plug in together, or that it's easier for other teams to consume your infrastructure. So that it's kind of like an overall, like with architecture in general, software architecture, system architecture, you think about that macro versus micro. So to me, it is about the kind of boundaries and how do you manage those, and again, it's about enabling sharing and enabling ways to empower teams.
Is there such a thing as like end-to-end test, or like I'm thinking of testing again. I keep going back to that because that's kind of what I'm struggling with in my current thing.
Yeah.
If you do have different teams managing different parts of the infrastructure, can you do something like contract testing in infrastructure as code?
I think you probably can. I think there's something around. I think about where the contracts are. A lot of the contracts with infrastructure is going to be between the teams building and running software, right? And so it's kind of more of that kind of contract between the layers, which becomes quite interesting. And yeah, certainly if you have so one team might be building like networking infrastructure, and then other teams are going to build maybe a Kubernetes cluster that's going to have to deploy into that networking. And so there's going to be that contract. What do I expect from the networking, right? What do I need from it? And so I think there's definitely room to do contract testing there.
Okay, my turn. Okay. I'm looking to see if there are any comments or any questions coming from the group. Okay, then we can continue on.
Other names in there. I love those.
Okay. Okay. One more. How do the principles of DRY, or do not repeat yourself, and YAGNI apply to infrastructure as code, especially concerning the creation and reuse of modules?
Yeah, so I'm always very cautious about DRY, the don't repeat yourself principle, where people are like, ooh, we shouldn't have code, in two different places that does, more or less the same thing, because that's going too far with that. And this is not just an infrastructure thing, but it very easily leads to tight coupling, where it's like you end up with the one thing, the one implementation, and then somebody needs something a little bit different from it. And then it's like, well, but lots of other teams are using that, and so you have to worry about breaking it, and so on. So I think it's, I think a certain amount of there's one definition, I can't remember. I think it's on the C2 wiki maybe, of DRY. I read somewhere where it was kind of making the point that DRY isn't about code. It's not about having code that's similar. It's about the concept. So for instance, you might have multiple infrastructure modules or components that implement a database for different needs for the database. Like if I need a database that is going to handle personal data and be used for transactional purposes versus a database that's tuned for other purposes. It's okay to have separate components for those things because they're doing different things, even though the code is they're both doing declaring database instances or whatever. So I think that's the level of DRY. You mentioned YAGNI, which I think is a big thing. Obviously, you ain't going to need it. This idea of do you build now for what you're might need later? So I'm a big fan of don't do that. I think the big thing is to make it easy to change. I think is the important thing. So build the simplest implementation you can. Make sure you build it well, so it's not about skimping on quality. And building something poorly. Build it well, build it simple, but also make sure you have the things in place to make it easy to change. Things like tests and so on.
Tests and tests and tests. Okay. So
we're dancing around that, rooting around the tests, are we?
It's really okay. In outcomes providing infrastructure works correctly, you highlight functional testing. For a team that's new to this, what are common traps that they fall into when defining outcomes for infrastructure, and how can they ensure their outcome-based tests provide meaningful value, but beyond simple resource verification?
Yeah, so I think that's the tricky thing. So I think you get most of people who develop infrastructure tend to come from two sides. You have the people from a more systems administration background who may not be familiar with writing tests and test-driven development, and that's the whole kind of curve to get through. I kind of encourage bringing in people with development skills into those teams so you can kind of get that. But then the people who come from development backgrounds, a lot of times they try to kind of replicate, the test pyramid in Agile, which is the idea that you have, a very small number of tests at the kind of top, the end-to-end sort of things, and then a lot of tests that are very low level unit tests. And I think the thing that we find with infrastructure is that those tests tend to have less value. And I mean, I've talked to people who have different kind of opinions on this and different feelings about it. But I find that when you have, like, say, a bit of infrastructure code which says create a subnet, and then you have a test which says, was the subnet created? That doesn't tend to have a lot of value, because if you run that and the subnet doesn't get created, the tool will normally fail, right? It's not going to kind of come back and say that it created it when it didn't, or say that the code ran correctly when it didn't. So for me, it's really around the tests are really around trying to catch risks, but what can go wrong. And also, when it comes to kind of the test-driven development thing, it's also around things that help you to move faster. So going back to making it easy to change something later. So what do I need to have in place to know that if I change something, I know I didn't break it, right? So I have that kind of confidence to do that. So the example I always like to give is around the networking. So it's not, was a subnet created, was a security group created, was the gateway created, was the network route created. It's, can I make the connection from A to B through all that stuff? Because that's what I always get wrong. I set all those things up and I apply it in all different place, and then I put my browser at it and it returns an error, and I'm like, where did it go wrong?
And what happened here? Right.
Yeah.
But it's got the resources.
Together. Yeah, not just the thing created.
It's because you mentioned the test diamond might be more applicable for testing infrastructure.
I usually talk about well, sometimes it looks like a diamond shape, maybe, that there's more in the middle layer, like the kind of thing that I talked about. I think there's also the Swiss cheese model that I talk about in the book as well, which comes from kind of a risk management thing. And it's the idea that, like, if you take a slice of Swiss cheese that has a hole in it, you can put your finger through it. But if you have a block of Swiss cheese, like, you can't. And so the idea is that at the different kind of levels, from what can you do when you're trying things out locally, maybe even before you execute it, so kind of static analysis type things, all the way through to testing of components, to all the way through to production, and look at monitoring as kind of like the final line of this stuff. And so you look at each of those as like a place where you can catch a potential risk, something that might go wrong. And you want to push it as far left as possible. You want to find out as soon as possible in the things that are easier and faster to run. So something that does a static analysis of your Terraform code or whatever, very quickly catches something. That's the ideal, right? But it's just thinking about it as a risk as opposed to trying to fill out a pattern.
Yeah, you also mentioned about testing. We shouldn't be afraid to test in production.
Ooh, there's a whole thing about the testing in production. I think for me, the thing there is, it's not about not testing before you put something into production. It's just that realization that, particularly for kind of larger systems, it's very difficult to accurately test before you get to production. And so it's good to be kind of, I guess, realistic about where the risks are and where you can catch those, and not see people investing a lot of time and effort and energy and complexity in their release process for things that make them feel like, we have to try to do these things before it can go live. And it's like, is that actually valuable? So it's worth asking that. But I definitely don't, it's not only test in production. It's just,
no, of course not. No.
Yeah.
Maybe not on a Friday night, a Friday afternoon. Testing production might not be advisable, that kind of thing. So could you also speak about the immediate testing and eventual testing? For teams just starting with infrastructure as code, what is one immediate testing activity that provides significant value for minimal effort?
So it may be things like, I mentioned static analysis, tools that just kind of check that your syntax and all that kind of thing is correct. Anything that you can test running on your local machine, that's accurate testing. And then the eventual stuff comes when you're putting more things together. So like the ultimate eventual thing is when you're actually deploying, say, applications onto your infrastructure and proving that, yeah, it does work. Everything works from kind of top to bottom, end to end.
Okay. I have a question about, because everyone's talking about artificial intelligence now, AI.
Yep.
Is it going to take my job? Will it just write my Terraform code for me? Or
there's lots of opinions on that stuff, right? I think there's some interesting things that we can do with AI. I'm really a big believer that it's most valuable when it assists what we do. It's not something that I would let cut loose. It's interesting. So I've been seeing a lot of, I guess, different experiments and things as what you can do with AI, and particularly with infrastructure provisioning. There's a lot of stuff you can do with kind of troubleshooting and all that, which gets quite interesting. But in terms of like infrastructure, defining and deploying infrastructure, I think some of the pitfalls. So I've seen one experiment which was essentially providing an interface where you can, like, say, create me an S3 bucket, and it's going to call the Amazon API and create your S3 bucket for you. This idea being that this can be a way to help developers, so they don't need to kind of learn the ins and outs of the infrastructure tools and the languages for doing that, to create the things that they need so they can deploy their applications, run their applications. I think the things to think about there are the same things. We go back to the principles of infrastructure as code. Even if it's not code, there are some principles there which are, you want stuff to be kind of transparent and visible and reproducible. So I'm going to use an AI to generate me an S3 bucket in my dev environment. If I do tell it the same thing to create it in production, is it going to pick it the same way to do it, or is it going to do something different? Right? It's not what's the term I'm looking for? It's not predictable. So I think that's something to be wary of. I think it can potentially help us with building infrastructure code, where it's assisting us, but I think we need that knowledge. So again, going back to that S3 bucket example of having the code, the AI create it for you. Well, I think I think there's a risk of it becoming just AI assisted ClickOps.
Yes.
To where, like, what is the right thing to create? Like, is the S3 bucket the right solution for it? What are you using it for? It's very different if you're using it to host web content versus you're hosting, let's say, medical images and so on, which need to be treated differently, and different kind of usages and all that. So I think in an ideal world, AI might be able to help us with that and give us some kind of tips and guidance and suggestions. But as with most AI usage, like, you got to bring your own, you got to know what you're doing with it, or you don't know what it's going to do.
It will sound so confident, and it may not be right if you don't have an idea of what it should look like, right? Okay, I'm going to we have a couple of questions in here in the chat, and then we'll do, let's see. Thomas Bloomberg asks, what are your thoughts on software development teams owning IAC? In a model where developers are responsible for IAC, what would the ideal RACI look like between the cloud team and the software development team?
That's a great question. I mean, I think development teams need to be empowered to be able to create and modify and deploy the infrastructure they need to do their thing. I think I think where, to my mind, I mean, but also you need the knowledge, right? Like we're just talking about, like, you need to know what's the right thing to create. There's a lot of depth of things that are really important for building infrastructure, that are kind of like their own areas. So it's things like security and performance and thinking about what's it like to run it and operate it and all of that. And so I think you have to have that knowledge in there. I think there are things we can do. I think my ideal RACI would be something around the lines of having people who really understand the infrastructure, building components, say, building the kind of tools and rails and guardrails and things to put in place. But I think the important thing for me is thinking about the kind of like the value stream mapping of you want to avoid handoffs, you want to avoid having to raise tickets, having somebody else do things. You want the team to be able to kind of say, like, okay, I need I need a database. It's going to store personal information, or it's not. It's going to have these characteristics that make sense to me as somebody working on the application, and then have it make it easy for the stuff to be assembled for them to use. I also think, as a part of this conversation, there's a whole kind of, I guess, the viewpoints around, say, abstraction layers and platforms. For my mind, when I talk about this stuff, I don't mean like it completely take it away from developers, like visibility of it. I know often there's this idea of like you don't let developers do things that they shouldn't do. To me, it's more around an abstraction layer is more around context. So when I'm working on an application, and I want to focus on the business logic and the things that that are at that level, and I want to deploy it. I don't want to have to stop and like wire together the network routes and gateways and things, right? But if I do need to, if there's something going on where it's like it's not behaving the way I need, maybe it's the network's performance is slow, I want to be able to shift down into there. And especially if I have the expertise or if I can have somebody help me, I want to be able to kind of get in there and then, okay, let me see what's going on. Let me understand what's going on, throughout those layers. So I think getting that balance right is really important.
Thank you. And now I think there was another question. Is it worth learning Kubernetes? Yes.
You need to know about it. So I'm like not a deep expert on Kubernetes. I have to confess. But yeah, it's one of those things. It's kind of need to know something about it. Kind of like AI as well. I would say. Like I know a lot of people are like, I don't AI. Oh no, but it's like I think you have to learn something about it, how to come to grips with it.
You have to know. You have to know at least when it's. A lot of people are using it. You need to understand what's going on and how not to use it is really important, and guardrails and everything like that. Okay. I might be pronouncing the name wrong. Mikola Nikishov asks, does definition of infrastructure as code include resources outside of the system? For example, provisioning developers, workstations, and the like?
I think it depends on your needs and your context. So I think because there's a lot of things you can define as code, and then there's the whole kind of thing of what is infrastructure? What is infrastructure? What isn't infrastructure? And all that. And I think it kind of, in a way, it's almost doesn't matter too much. It's. I think there's a couple of things. So one is the consistency across the kind of the path to production. And so a big reason why infrastructure as code is become so popular. It's as a part of continuous delivery and DevOps and all this stuff is it helps to alleviate some of the problems we used to have and still have in a lot of places where you have different people building different environments in that path to production at different times and in different ways. And so then you're constantly wrestling with, okay, we got this to deploy in the staging environment. Now we have to do it in production, and that's going to take another week because we have to kind of spend so much time trying to figure out why it's not working the same way and blah, blah, blah. So I think particularly development environments, finding those ways to make sure that it's consistent across, I think is really important. It may be, I think there's a development environments are used in very different ways, especially like local development. What I'm writing my code and I'm running my tests and I'm trying it out and all that. Like that's a very different use case than say in production. And so I think you do have to be careful not to try to force fit tools from one end of the path to the other, where it might make life difficult, right? And so I think. But I think it's as always, it's thinking about what do I need? What is a useful consistency between what I'm working on locally and what's in production? How can I bring, get fast feedback so I'm finding issues as much as possible locally, rather than in production. And so it's not a kind of straight answer on that clear cut. Because there's all kinds of things, monitoring and stuff like that. I think it's really useful. Again, you see things like where teams have like expensive monitoring solutions. I won't mention any product names, but like there are some, things that do log aggregation and analysis and all that are super, super expensive. They get really expensive when you put them on production or on development systems because you have lots of developers and testers doing all kinds of crazy stuff. And so it's only in production, and then you don't have access to it in development. And so again, if there are things you can do with code-driven things to say that your monitoring is set up in the same way. So when I'm working on development, monitoring the same kind of monitoring maybe tells me, oh, something's gone wrong here. And that's valuable, right? And that also then helps you have that kind of insight. If something goes wrong in production, you're familiar with the tools rather than being alien tools.
Yeah. Oh, that's excellent. Thank you. There's another question from Simon about sustainable web development principles. How do sustainable web development principles matter in your research and practice next to performance and uptime?
So I'm not sure what sustainable web development principles is. That like a specific kind of thing? What are we
Let's see if
talking
they
about?
will follow up.
Could it be about energy or something like that? Energy usage?
Could be about energy usage. I was thinking in terms of maybe the types of resources you deploy. If you are the LinkedIn user would have to be
Yeah,
more
they
specific.
can kind of maybe expand on that a bit.
They can expand a bit
We can,
there.
we can.
Okay. Someone asked, we'll move on and we'll circle back. What is the advice that you give to a tester who is starting his or her career in today? What are the top 3 areas they should focus on?
That's a good question. I mean, yeah, it's a really good question because, so to me, I mean, obviously I don't come from a testing background, but I work a lot with testers, and it's always very important to me on when I'm working on projects. Like testing is often a big part of it, and often not the first thing that people think about. That, like, when, say, clients ask us to come in and help them with their software delivery processes, and how can we, they'll come to someone like me and say, can you help us deploy our application faster? And it's like, yeah, well, let's have a look at overall what's going on. And often, like, testing and what are you doing in testing is the is super key to everything. And so I think it's important to not over focus on. I mean, obviously you need to learn some, like, specific skills around, like, maybe whether it's test automation or those kind of things. But I think that it is the mindset and the kind of strategy, and it's the risk management. It's really understanding the why um, of everything, and then the specifics of, like, say, using a particular test automation tool, or even whether you're doing test automation yourself or you're working with developers who do that bit, or what have you, is kind of like that's the how, I guess, but understanding the why, I guess, is really important. I'm not sure if that was helpful or not. Sure.
It's pretty good. It's a start,
Yeah.
In chapter 17, you emphasize continually testing infrastructure code, moving away from the build it, test it, and use it mentality, right?
Yeah.
What are some of the biggest organizational or cultural hurdles that you observed in teams trying to adopt this continued testing approach, especially companies or teams that do not come from, like, a agile software background?
Yeah. I think there's often a mentality that infrastructure is something that you just build once and then it's done, right? And so we talk about using automated testing and putting that into pipelines and all that. And I often get even people who are totally on board with doing that for software, like, well, why would I need to do that for my infrastructure? We're just going to build the environments, we'll set up the database, and then it's done. We can test it and just make sure it's okay. It can be done manually because it's faster to do than writing a test suite or what have you. And isn't that fine? But I think people underestimate how much we actually do change infrastructure, and how frequently. It's basic stuff, like, obviously there's, like, patching and those kind of things, but there's also the small configuration changes, improvements. Then there's the tweaks that we need to make because of changes in the software, and we need to do something to the database configuration or what have you. And I think those things add up. And what happens is, if you're making those manually, they tend not to be made consistently across different environments, and then you get more and more kind of divergence in how different environments work. And then you'll get something critical that comes up, like, oh, there's some security patch that needs to be rolled out quickly because there's a big vulnerability. And then it's like you start rolling it out, and it, like, breaks on some systems and not on others. And so I think it is that mentality, that kind of, I guess, recognition and understanding that, yeah, infrastructure really does change more than you probably expect. And so, we've got to do that. I think the second thing is just the tools for testing infrastructure are still very difficult and not very mature. And so you end up doing a lot of work putting those in place and working on the test suites and all that. And that's just a big, it's a big hurdle. And so I think that puts people off as well.
Yeah. Okay. We have a follow-up about the sustainable web development, asking about green hosting or efficacy of code or resource-aware development in terms of green. Should that be a part of IAC?
Yeah, but I think it should be a part of everything. But I think the more we can do to kind of, I mean, I think it's very similar to the cost thing, and to a certain extent, cost can be kind of a proxy, and it's kind of that can be kind of beneficial just in the sense of like, the executives care about how much you're spending on your cloud bill. And so if you take measures to bring that down, that often as a side effect, can help with the energy consumption. It's not always, it's not like a one-to-one thing. So I think making those things visible,
like right sizing your instances and stuff like that, just to make sure that
how much are you spending, and there are some things around, like some data centers, or like some regions that you can host in with your cloud provider, are more environmentally kind of like some, they have different energy sources that they use. Some are more use more kind of green energy sources than others, and so that can be a factor. Off the top of my head, I know there's some kind of resources around this, and we've at ThoughtWorks have published some stuff, and we collaborated on a tool that helps to kind of do a carbon I think usage calculation for your infrastructure. I don't have off the top of my head the maybe one of our colleagues who's in the chat can share that, or can share it after.
Okay, we're going to follow up with Harina. Asks. It says, I acknowledge that infrastructure as code will assist in preserving consistent configurations across multiple environments. The question, is it possible for us to include stress testing with different IAC implementations? And additionally, should we consider the differences in processing power as certain functionalities such as TLS, handshake, and hashing demands significant processor resources for managing streaming or high latency systems?
Yeah, so I think there's a couple of things here. So one is the consistency across environments, and I've been starting to use the term meaningful consistency meaningful is the right word, but like relevant consistency, I guess, because there are obviously going to be differences between environments, like in the size of how much you provision and so on, and maybe even the size of instances and those kind of things. So I think that's one aspect, and I think you have to take that into consideration. Those differences then can have an impact on the on performance issues. I think it's something you kind of have to deal with. So I view the kind of stress testing and performance testing as something you have to do as a overall with your testing of your systems at various levels. And if you can test at just the infrastructure level, you also need to test with the software, obviously, to kind of get the full picture. But you can kind of get some indicators from them. And I think that's part of that overall strategy, which I would say is kind of a broader kind of quality and risk management strategy that you need to consider. And but it's so much of it depends, right? So those kind of factors that you mentioned there, Harinath, you mentioned the handshaking and all that kind of stuff, like that may or may not, like in some environments and some systems, that kind of thing can be really important to make a big difference. I think as usually with these kind of things, you start from kind of the broad, what's the kind of end-to-end performance, and then you kind of do an analysis. If that's not what you need it to be, you do an analysis of where is the most fruitful areas and where is the most time going. So rather than kind of diving into specific areas and saying, oh, I can see how to optimize this, it's like, well, what's going to give me the biggest return on optimizing. That's a massive topic.
Yeah, it's a massive topic. That's a separate session. I think it could be. Okay, we have another one from Sapna. What strategies do you use to manage drift between deployed infrastructure and IAC?
So there's two different ways that the term drift and configuration drift is used. The old school way was between environments. So how much difference is there between my production and other environments, or particularly when you're manually updating stuff? And so that's around using kind of like pipelines and stuff, and making sure when you make a change to any environment, you do that change in code, and you roll that code out to all of the kind of environments where it's applicable. So that it's you have as short a gap as possible between for that time where systems might be configured differently, again in that meaningfully different way. But then there's the whole thing these days with you've got your code, and then you've got your running infrastructure, and what when do you apply that code, and over time, like there might differences might creep in somehow, particularly if somebody makes manual changes to systems, or what have you. And I think to me, just like continuously running your infrastructure, so you shouldn't just run your infrastructure code just when you do deploy a change. Ideally, you have like a loop that runs continuously, that reapplies to let you know, or to make sure that everything is kind of reverted to, this is the specification, this is what it should be. And that
So
kind
that
of
would
has
be
a
in the
side effect.
pipeline, like in the
Yeah, in the
pipeline. So you just
pipeline
have
and even outside of the pipeline, right? So even, well, it depends on what your actual deployment mechanism is. So you could have your pipeline could have a stage that just runs, not just triggered from a change, but like runs on a schedule. Or you could be using like a lot of these tools that are out there now for deploying infrastructure code, do that, that kind of reconciliation loop, very kind of GitOps kind of way of thinking about it. And I think the thing there is because what often happens is people make manual changes to infrastructure rather than the code because it's easier and quicker, especially in an emergency. But then that leads to kind of creating that drift and makes it really hard then to apply that code again and to bring that back in line. And so you just have to make it as easy as possible where making the change in the code is the kind of path of least resistance. And it's a thing that you do because it's easier to do and you're more confident doing it. And then that helps, that reconciliation loop then kind of helps to enforce that.
Okay. I think we have time for a question from one more question. I often find internal platforms offering infra as service to struggle with designing or predefining patterns that do add value to developers. However, I still like to believe a balance must be found to remove cognitive load from developers and truly enable it. And any thoughts or tips on that?
Yeah. Yeah, it is a tough one, right? And I think I blame some of this on the tools. And so this is where, like, for example, going back to Terraform being kind of dominant tool and the models that it puts forward. So the Terraform modules, I think, are very difficult. It's very difficult to build modules which are then reusable because the way modules, the Terraform language works, it's very, it's declarative. And so it's hard to kind of write code that can be used in different situations without getting really, really nasty. So I think that's one thing to blame it on, but I think really it does come down to how, who's building those hopefully reusable code modules, and how are they doing that? And that really has to be done in conjunction. In fact, ideally it's done, you build code modules because there's a team that's trying to do a thing, and so you help them to do that or give them the ability to do that themselves, and then share that, rather than having a team sitting and saying, I think teams are going to need this, and so I'm going to build this and put it out there, and then teams look at it and say, well, that's not really what I need, so I'm not going to use it. So it's kind of this classic tool development, platform development, like you really need to have that kind of product thinking about it. You need to be collaborating tightly with the people who are using it, rather than trying to do it in a from an ivory tower or what have you.
Yeah, ivory tower. Amazing. That's our last question. I just want to remind everyone, Infrastructure as Code, the 3rd edition, is now available. It's an amazing book. It's useful for you if you're starting out. Really useful if you're starting out, as well as continuing on the journey in Infrastructure as Code. It provides a way to think about this, a high-level way of thinking about this beyond the specific tools. So I highly encourage people to go out and find yourselves a copy of this. Thank you again, Kief, for joining us here. This was an amazing conversation. I hope you enjoyed it as well.
I enjoyed talking with you and the folks on the chat. So yeah, thanks.
Thank you.